The hydrological transformation of agricultural landscapes through PQNK, picnic.
सत श्री अकाल बाई जी, सारे ग्रुप वाले वीरां नूं सत श्री अकाल जी। मैं जसकरण सिंह, इंडियन पंजाब डिस्ट्रिक्ट फाजिलका तो मैं आसिफ अंकल जी दे कहने ते उन्हां तो गाइडेंस लैके उन्हां दे ग्रुप विच जुड़ के मैं बैड बनाए सी बाग दे विच, खालियां बनाईयां सीगियां क्योंकि बाग अपना वड्डा सीगा ते बारिश पिछले 3-4 दिनों तो बहुत ज़बरदस्त हुई है तो पानी फिर भी नहीं खड़ा गा। पानी बस थोड़ा बहुत खालियां दे विच खड़ा है। ये भी खड़ा तां है क्योंकि मैथों हार्ड पैन नहीं ब्रेक होया, सिर्फ खालियां बनातियां पर हार्ड पैन नहीं ब्रेक हो सकिया। तो उधर तुसीं जे दूजे खेतां च देखो तो पानी बेथाक आ देख लो तुसीं, बहुत ज़्यादा पानी खड़ा है। हुण तो कुछ घटिया विच नदीन थोड़े दिसन लग गए, नहीं तो बहुत ही ज़्यादा पानी खड़ा सीगा पर अपने नाल दी नाल ही खत्म होंदा गया। ये देखो ये बहुत पानी है जिहड़ा दूजे खेतां दे विच खड़ा है, जिहड़ा आम वाह के रखा हुआ वाहन है, वाह के सुहागा मारे। बहुत धन्नवाद जी।
हाँ जी भाई जी, ग्रुप के सारे मैंबरां नूं सत श्री अकाल। कुछ मैं गल शेयर करनी सीगी। वैसे तो इस ग्रुप च सारे ही बहुत एक्सपर्ट है, मेरे तो सारे एक्सपर्ट है। फिर भी मैं कुछ जिहड़ी चीज़ वेखी समझी वो मैं क्या चलो शेयर कर दईए। तुसीं देखो बाई जी, अज साडे नाल बारिश आई है बहुत ज़्यादा, भी घट्टो घट्ट 50-50 उंगलां होनी है जी। बागां दे विच पानी खड़ गया फुट। ये आपां जिहड़े बैड बना रखे पिकनिक ते जिहड़ा आपां कर रखिआ बाग नूं, इहदे विच सिर्फ नालियां च थोड़ा थोड़ा पानी है ते इस जगह ते बिल्कुल भी पानी है नहीं। देखो तुसीं जमां वधिया, मैं जिहड़ा चप्पल पा के इहदे उत्ते चल सकदा। ते तुहानूं मैं साडे पड़ोसियां दा बाग विखाउणा जिहड़े रवायती तरीके नाल कर रहे है, वो भी दिखा दिना भी की हाल है। इधर देखो बाई जी, खाले खूले जिहड़े अद्धे होए पे है। इधर वेखो किन्नू शिन्नू सब थल्ले आ गया बाग दा, मुड्ढा नाल पानी खड़ा है फुट घट्टो घट्ट। ते जिहड़ा बैड ते बाग करन दा बहुत ज़्यादा बेनीफिट होया है। लोग बाई जी अखी वेख के भी यकीन नहीं करते। जे इस बाग दे विच कल नूं बहुत तेज़ धुप्प निकलदी है ना, तो इन्नी भड़ास निकलेगी तो इहदा किन्नू मेरे हिसाब नाल भी घट्टो घट्ट पहले झटके 20% थल्ले आ जाना। तो अपने तो बाई बहुत वधिया खड़ा है। सो बड़ी मेहरबानी डॉक्टर आसिफ जी दी, जिन्ना सदका सानू कुछ चानण होया, कुछ करन दा तजर्बा आया। बहुत बहुत मेहरबानी जी। असी तो जंतर शंतर लगा रखिया है, पहलां वढ के मल्च मुल्च करती सी, दोबारा फेर लगाता सी। ते वधिया नज़ारे आ, भावें 20 उंगलां होर आ जे, आपां नूं कोई डर नहीं गा। हाँ जी बाई जी, सत श्री अकाल जी।
This paper elucidates the hydrological principles underlying the Paedar Qudratti Nizam Kashatqari, PQNK, the regenerative pristine organic farming system. Through the systematic elimination of hard pan and the emulation of forest soil ecology, PQNK transforms farmland into a high infiltration, flood resilient, and drought-proof landscape. Empirical observations confirm that soils under PQNK can absorb extreme rainfall events, greater than or equal to 600 m/day, without runoff, thereby recharging groundwater and mitigating flood risks. Introduction: The problem of hard pan. Conventional tillage and compaction create a hard pan, a dense, impermeable layer 6 to 12 inches below the surface. This hard pan limits root penetration and soil aeration, causes ponding and runoff during heavy rain, exacerbating erosion and flooding, disconnects topsoil from subsoil, disrupting the natural hydrological cycle. Farmers' long experience of flooding and waterlogging is a direct result of this anthropogenic soil degradation. The forest analogy, nature's blueprint. In undisturbed forest ecosystems, no hard pan exists due to continuous biological activity, roots, fungi, earthworms. Infiltration rates exceed rainfall intensity, preventing overland flow. Soil acts as a living sponge, storing water in depth and releasing it slowly to vegetation and aquifers. PQNK adopts this blueprint, aiming not merely to grow crops but to recreate forest-like soil function within agricultural plots. The PQNK intervention, breaking the hardpan. The first step in PQNK is deep subsoiling without inversion. Mechanically fracture the hardpan, to 18 to 24 inches, using subsoilers. Avoid turning soil layers to preserve microbial habitats and organic stratification. This opens vertical macropores, re-establishing hydraulic connectivity between surface and subsoil. Deep subsoil revival, the living architecture. Mechanical breaking is temporary, permanent stability is achieved through biological structuring. Role of deep-rooted plants. Jantar, Sesbania aculeata, trees, moringa, gliricidia, fruit trees, and perennial grasses are planted on raised beds. Roots are never uprooted, they are retained in soil. Their roots penetrate 10 to 20 feet deep, acting as biological drills. They create stable biopores through root exudates and physical channels. Enhance soil aggregation and carbon sequestration at depth. Facilitate nutrient cycling and microbial colonization in the subsoil. The raised bed advantage. Raised beds improve surface drainage and increase rooting volume. Interspersed trees and deep-rooted plants become permanent subsoil lifelines, preventing recompaction. Hydrological capacity, the 600 mm absorption phenomenon. A PQNK prepared field demonstrates infiltration rates greater than 250 mm/hour, derived from soil physical changes. Macroporosity increases from 5%, compacted soil, to 15 to 20%, PQNK soil. Continuous pore networks allow gravity-driven percolation beyond the root zone into deep groundwater. The infinite depth principle. Unlike hardpan limited soils, PQNK soils have no lower barrier to infiltration. Water moves freely into the vadose zone and aquifer, turning each field into a recharge basin. Flood and drought mitigation. Zero runoff during extreme rain eliminates contribution to catchment scale flooding. Recharged groundwater emerges as base flow in dry seasons, securing water for wells and springs. Evidence and farmer testimony. The initial disbelief of farmers, e.g., 600 mm in a day seemed impossible, transforms into experiential truth upon observing. No standing water after heavy rain. Increased well recharge and soil moisture retention. Crop resilience during both deluge and dry spells. Implementation framework. To transition a farm to PQNK. Assessment. Identify hardpan depth using a penetrometer or simple digging. Deep subsoiling, once, before establishing beds. Bed formation, create permanent raised beds. Rotation, plant crop after crop with a no-till planter without disturbing the soil to retain roots and save soil structure. Mulching, maintain organic cover with crop residues to foster soil biology and protect pores. Conclusion, from flood sink to water source. PQNK represents a paradigm shift from drainage-based to infiltration-based water management. By breaking the hardpan and installing a living root network, farms can achieve forest-level infiltration capacity, absorb cloudburst-scale rainfall, contribute to regional hydrological stability. The system proves that agriculture need not be extractive, it can be regenerative, resilient, and a solution to water crises. The land does not flood, it thirsts for rain. Our duty is to open its throat. PQNK principle.
PQNK, a viable solution to water management. Improves water infiltration. PQNK helps water to penetrate the soil more quickly and easily, which can help to prevent flooding and erosion. Saves soil and plants. By preventing water from inundation, PQNK protects soil and plants from damage. Recharges aquifers. PQNK can help to recharge aquifers, which are underground water sources that are vital for human and agricultural use. Manages floods. PQNK help to manage floods by infiltrate water, where it drops and slows the flow, reducing the amount of water that adds to floodwaters. Grows crops without irrigation. PQNK can help to grow crops without irrigation, which can save water and reduce the cost of agricultural production. No need for expensive dams and distributaries. PQNK reduces water loss by eliminating evaporation, making it a cost-effective solution for water management. It does not require the construction of expensive dams and distributaries. PQNK, the future of water management. PQNK is a promising new understanding that has the potential to revolutionize water management. By improving water infiltration, PQNK can help to prevent flooding, erosion, and water shortages. It can also help to grow crops without irrigation, which can save water and reduce the cost of agricultural production. PQNK principles: breaking hardpan, making permanent raised beds, soil cover with organic mulch.
Footnote: PQNK, pronounced picnic, the regenerative and sustainable Pristine Organic Farming System, is grounded in natural ecosystem science. This science employs perennial biodiversity, protects soil with organic mulch, and avoids practices like water inundation, tillage disturbance, and leaving soil bare.